Hello, hello. Sorry, I'm late. I am late. Hello, hello. Good to see you guys. Very good to see you guys. Sorry, I'm late. Was finishing a different class. Sorry, more people coming. Hello, hello. Good day. Here we go. Ah, yes, this class. Right. Okay, hold on. Good, good, good. I knew that. I mean, I knew it was. It's good. Okay. Awesome. And there's so much video. It's like overwhelmingly cool. Coolly overwhelming. Yes. Hello. I'm going to do it in this. Actually, I'm going to do it in this order. First, I'm going to say hello, we, she. Hello, Jessica. Hello. So I'm saying hello to the videos first, just to be obnoxious. Then I'm saying hello to the chat. So hello, we, she. Hello, Jessica. Hello, Nicholas. Hello, Elizabeth. Hello, Andrew. Hello, Catherine with a K with a Y. Hello, well, Catherine with the I also, although that's about, okay. Hello, Ruby, who's been waiting here since 19, she was like totally first, like about 400 minutes ago, but I'm not saying that at all. Hello, Manoj. Hello, Jaylin. Hello, Althea. Hello, John. Hello, Alyssa. Hello, Zemin. Hello, Eric. Hello, Maisha. Hello. Now I'm going to do it the other way. Am I stalling? Yes, probably. Hello, Nicholas. Good afternoon, Manoj. Good afternoon, Althea. Good afternoon, Andrew. Good afternoon, Jaylin. Good afternoon, Wishi. Hi, Alona. Hi, I keep thinking that this says beasties, which is like not what it says. Good afternoon, Jessica. Good afternoon, Zemin. Good afternoon, Elizabeth. Hello, Ruby. Again, and hello, emoticon, emoji. Good afternoon, Eric and everyone. Hello, Maisha. Hi, Catherine. Hi. Now, wait a minute. Now John's getting feisty. Okay. Hi. Well, that can't. Okay. Yes. Hi, John and Misha. Okay. Good afternoon, Alyssa. Oh, more people coming. Oh, 4 more people coming. God, I thought I was late. They're like crazy late. Oh my God, I'm gonna totally embarrass it. Good afternoon, Alyssa. What's with the deal with Mish? All right, well, all right. Wait, who? Oh, and more people. Wait a second, wait a second. Actually, who's is Mish Maisha? Mrs. Maisha, right? Okay, yes, okay. So she's like the popular one. Okay, she's the one that would scare me if I were a student right now. Okay, got it, got it. Good afternoon. Oh, no, she wouldn't. I'm just kidding. She totally wouldn't. Yes, she would. Okay, good afternoon, Alyssa. Good afternoon. Okay, what's up, Maisha? Good afternoon. She doesn't even show video. Okay, whatever. Hey, what's up? Yes, that's me. Okay, yes, okay. I'm totally intimidated by you, Maisha, just because you seem to have this class in the palm of your metaphor. Okay, good afternoon, Rachel. Hi, Leslie. Good afternoon. I'm not going to get this wrong. I'm just going to make a big dramatic spazzy production about it. No, wait, Alea. No, no, wait.
Yes, you got it right.
Okay, I'm just going to move. Yes, thank you. Okay. And you just got voice points too. Great. Oh, and I just lost my. Oh, that's so even my computer celebrated by shutting down my tablet. That's fantastic. All right, I won't push my luck, but thank you. Thank you for good. I'm glad. I'll never get it wrong again, except when I tell, hi, nerd. He must be talking to me. Oh my God, John, that's feisty. Okay, I'm trying. Oh, you're trying to change your avatar. Okay, okay, cool, cool, cool. Wow. Okay, good afternoon. It's not letting me. Yes, I know the feeling. I have to put my screen back on in a second. This class, if I'm not careful, clearly you guys have already figured out, but if I'm not careful, you could potentially succeed in getting me to never do physics with you. That's how much I like, but I wouldn't do that because I like you too much and I don't want to deprive you of the gift. Plus, I'm going to have you in 204 and you need to be prepared. I totally don't understand what Althea wrote there, but I sort of do. I still don't even understand the whole @ sign thing. I'm so behind. All right. Street name. No way. Whoa, your street name. Okay. Do you know how much these physics equations, street value? I mean, they're cut. These equations are like diluted, but even on the street, they go for. Okay, I'm not saying. Well, how did you, bro? Oh my God. Okay, I'm not going to get involved in that. You guys will help her. Gift of it. Yes, it's a gift. Yes, you will succeed. That's true. You'll also succeed in 204 and keep me off the topic, I'm sure. Okay, no, it's cool. All right, I lost my board. God, no, seriously, the ratio of video and enthusiasm and humor and everything in this class to whatever else is like so high. I love it. Also, wait, more people coming. I'm going to try to put my board back. I'm not trying to stall now. I'm trying to get my board back on before we go further. I don't know why I got lost. What? Where did? Okay, here we go. Okay. Now, yes. Okay. And we might as well even. Don't worry about that's not for a different class. Don't worry. Hold on. I mean, you can worry if you want. We want this. Okay. Okay. Right. Okay, that's us. I'll discuss that in a minute, or I'll explain that in a moment. But this is us. Welcome to us. Also, one more quick praise of this class. I mean, see, and you'll the profile. Okay, I'll let you go. Okay. One more compliment to this whole class. Well, first of all, thank you again for rolling with the fact that I'm still behind you. You're ahead of me. I know that. You know that that's a good thing. And you, okay, I'm gonna run at you. Like I still owe you back stuff. I'm aware of that. It's hopefully you're seeing that you're getting stuff from me though. Like most of you have turned in more to me than you've gotten back. I'm aware of that. I'm not proud of it, but I'm aware of it, and it's not personal. But also, most of you hopefully are continuing to get things back. Like you got, they might be small things, but hopefully you got things back today, such as game assignments. May not be the stuff you care about as much as the actual physics. Fair enough, but just know that as long as you're getting stuff back at all, it means, you know, I'm just behind and I'm just still catching up and we're rolling together and I haven't abandoned ship. As long as you're still getting stuff back, it just means, you know, there's a delay. Pretty soon I will have to assign a homework 4. I know I haven't done that since 1969, but I'm not, certainly you're not going to be suddenly surprised and have a homework 4 due 2 days from now. That is not going to happen. Like there's definitely nothing new due this Wednesday. By this Wednesday, we will be discussing homework 3. I can assure you of that. By this Wednesday, we'll be discussing homework 3. So if you have done it, cool, maybe refresh yourself of it or get, and you wouldn't have gotten it back yet. But if you've done homework 3, maybe just remind yourself of it, like get it ready for Wednesday, because it's going to lead to a discussion. It's meant for a discussion. If you haven't done homework 3, you still totally can with impunity. You know, with no harm, no foul, but please do. It is about time. So we will discuss it Wednesday. Today, we're going to finish going over homework 2. And I still know that a lot of you have homework 1 and homework 2 to get back from me. I just said that, but again, I'm aware. Why am I saying all of this? I'm saying all of this to say, oh, good, it worked. Oh, okay. Okay, cool. Okay. Oh, I see. Right. Yeah. Okay. I'm saying all this. Quick praise to the whole group. You know, the fact that you're here at all right now today is kind of impressive and cool because, as I'm sure some of you know, if you were like super responsible and check like calendars and things all the time, you might have caught that this weekend there was a crazy error that was actually very unprecedented and confusing, where it suddenly seemed like there was a calendar posted on the web from the John Jay registrar that seemed to indicate, i.e. said straight up, that there were no classes today and that tomorrow is a Monday schedule. Now that turned out, yeah, like, wow, right. Don't get me started. But yes, that was a classic example of City University of New York embracing the distinction between precision and accuracy, something you all learned about in chemistry, I think, right? Like CUNY is so precise, but it is often not at all accurate. And that can be very confusing at times. So yeah, that schedule, of course, you have to be the kind of person that would pay attention to such schedules anyway, which is not me, but that schedule did come out Sunday. And then I got all these emails and stuff from my adjuncts and like, what's going on? It was a total error. It was a total registrar brain fart. I still don't understand it. And they tried to retract, they tried to change it, but the information was already out on the web. So there you go. So, you know, I mean, if you showed up today and now you leave, I'd be a little bit scandalized and a little bit not sympathetic. But, you know, if you hadn't made it at all today, I would too late, sorry, but I would understand, because it did look as though there was no school today. There totally is school today, but also on that, in case anybody's still confused, there is, school is normal tomorrow as well. Like that was just a complete error. School is normal tomorrow. And I will say this too. Wait. Now, actually, okay, I kind of love what Nicholas said there. That's very honest and humble. Well, me too. I mean, all right, so I shouldn't make, that is funny what Nicholas said. And wait, was it really a prank? I don't think it was. Oh, that's a joke. Okay, that's like a double prank. It's a meta prank. All right. How to adult. Oh my God. All right, I'm gonna stop. All right. Anyway, thank you for being here. And tomorrow is normal. I'm actually gonna say right now, I'm gonna regret saying this. I should get rolling in a minute. I should get rolling on finishing up homework too. I mean, that's what we're going to do in a second. But actually, I should take this moment to admit, and I'm good. This is going to, I will send emails out again. I will send you out warnings and everything and give out points and try to make sure this goes as smoothly as possible. But I will warn you right now, if you're paying attention, this Wednesday is yet again one of those Wednesdays when we actually won't meet. Like this class won't meet this Wednesday. Sad for me to say, it's like the alternate Wednesday where I have to teach a different class. So this is, I will send out the emails and everything and give the points for acknowledgement, but just so look out for it. This Wednesday, you're going to watch the video from the other class instead of having class, right? Like that happens like every 2 or so weeks with us. I will send out the email. I will try to be clear, but I know it's still confusing. We don't actually have live class this Wednesday. I will just ask you instead to watch the posted video of the morning class, same material, same everything, just not same fun. Okay, so I will say that again. I will print it again. But if you're planning your life, you don't have to, you can't be here at 3:05 this coming Wednesday. Oh, and you saw that. Okay. In fact, actually, can I just, to save myself a little bit of heartache, can I just get, there's no points right now, but can I just get in the chat, just like yes confirmations from all of you or hand raising, whatever, just to confirm that you're hearing me, that this Wednesday, we will not have class. You will watch the video from the morning class. Thank you so much. That's awesome. Thank you, Althea. Thank you, Alona. Thank you. Thank you. Thank you, Mark. Thank you, Rachel. Thank you, Lisa. Thank you, Michaela. Thank you, Alyssa. Thank you, Catherine. Thank you, Elizabeth. I love this. Thank you, Mish. I mean, Maisha. I don't know if I'm cool enough to say Mish. Oh, she changed her thing. So, okay. Yes. Thank you. Yes. Thank you, Mark. Thank you, Zeman. Thank you, Manoj. Thank you, Ruby. Thank you, Alea. Thank you, Nicholas. Thank you, Wishi. Thank you, Catherine. Thank you. This is great. Thank you, Andrew. Thank you, Rachel. Thank you, Jessica. Okay. I think that is actually awesome. Awesome. And 2 people raised it. All right, I think that, and Jiawei, you got that? Wait, I think that's the only person that, wait, it's Starnisha, you got that, right? Oh, yes, yes. Oh, no, wait, Starnisha, now I'm calling on people, which is, wait, sorry, Starnisha and Jiawei, did you catch we don't have class this Wednesday? I'm just trying to say, yeah, great, thank you.
I followed that.
Okay, great, thank you. Okay, awesome, awesome. Okay, okay. Okay, awesome. Okay, okay. And I will miss you, believe me. It's gonna like, it's like a rough hole in my life when I don't get to see you guys. No joke. All right, so let's just move on or back to physics. This has reference. All right, let me tell you where life is going. Right now, we still only have 1 equation, believe it or not. Of course, we're going to get a lot more equations. Of course, physics involves a lot more equations, but I go slowly at first, as you can see, because I'm a real firm believer that physics is about really understanding and developing the equations and taking them super seriously. It's not about memorizing a million pieces. It's about having very few pieces and learning how to work with them. So all we've been analyzing for a couple of weeks really is average velocity and average speed, 2 very related concepts. Average speed is distance over time. We generally just express that in English. But then once we're really into the rigorous, once we include the concept of direction and we get a little bit more precise and rigorous, and we talk about average velocity equaling displacement over time, we usually express that as an equation, V bar, triple equal sign, x minus x naught over t. That is the only equation that we're responsible for right now. That on the one hand, that's the good news. The only equation we're responsible for is that one. On the other hand, the tricky news that I'm trying to get across is that like that equation has a lot more meaning than might meet the eye. We can do a lot more with that equation than we might think. We have to do a lot more with that equation than we might think. And we're also not allowed to do anything but what that equation says, right? And that's, so what I'm really trying to get across in these early problems, which might be frustrating to some people, what I'm really trying to get across is like the actual meaning behind average velocity and average speed. For example, the problem that we just finished last Wednesday, the Hill figure up down problem, right? Part of what that's really trying to get across is, okay, average speed might sound like pretty straightforward. It's just like distance over time. But let's, before we go any further, let's note that average speed is distance over time. It ain't average of speeds, right? Like that's the cautionary tale that problem is trying to say. It's trying to say, don't, now again, and that's a tricky thing to say, because you might say to yourself, well, freaking, like, why? I mean, then why does physics call it average speed? That's so annoying. Like, why would you call it average speed if you can't just average the speeds to get the average speed? Like, are you just trying to mess us up, yo? And the answer is no, we're actually not trying to mess you up, comma, yo. What we're actually saying is average speed actually really is an average. Oh, it is. If you really understand the meaning of average, it is. The average speed that dude went going up the hill and down the hill is actually 48. But you have to really take seriously what an average is. And you can't just assume average doesn't always, the average of a few numbers doesn't always mean take the two numbers and divide by 2, right? It actually, like, that's just a method for getting an average that sometimes works when you have a very simple example. But it's not a method for getting an average that always works. It's not a method that always works if average means one value that represents the whole, right? Just to remind you again, like where we were like on Wednesday, like remember, if the only 2 test scores you ever got in a class, not this one, were a 40 and a 60, right? If the only 2 test scores you ever got were 40 and 60, but you got a 60 twice, and you got a 40 3 times, right? Like, and that's the situation. You only ever got a 40 and 60, but in fact, you had 5 exams and you got a 40 on 3 of them, and you got a 60 on 2 of them. Then your average would not be 50. You wouldn't just take the 40 and 60 average. Like if you saw it all spread out, you would see, you would want to like go 40 plus 40 plus 40 plus 60 plus 60, add them all up and divide by 5. Or if you were really clever, what you might do, same exact thing, you like if you saw that fact, you might say, oh, I get it. It's like, yeah, my only 2 numbers were 40 to 60, but it was kind of like the 40 was weighted 3 times in the average, and the 60 was like weighted 2 times. Like it's like a 40 and 60, but a 40, I did 3 times as frequently, and the 60 I did only 2 times as frequently or whatever. So you might say 40 times 3 plus 60 times 2 divided by 5. That's technically called a weighted average. That would be averaging, but you'd be averaging very carefully. And if you did that, you'd get the answer 48, right? Which makes sense because, and I mean, these numbers are very depressing if they were test scores, but if your average would be 48, not 50, because the truth of the matter is you were getting 40 more frequently than you were getting 60. So your average is closer to 40 than it is to 60. That's what happened on the Hill. That's what's happening in the physics. Like average speed, make no mistake, it does mean average speed. It's not a coincidence that we use that word, and it's not a trick, but it doesn't just mean take 2 numbers and divide by 2. It means total distance over total time. What it really is saying is let's take into account, like, let's recognize, we're asking how fast we were going per time. It's like distance per time. So if we spent 3 times as much time going 40 as we did going 60, that's exactly equivalent to the test score. And that's what happened on the Hill. We spent, because we went up a hill at 40, we went a certain distance at 40, we're going slowly. So we spent a lot of time doing it. Then we came down that same hill, but we came down quickly. So it took us less time to get down that hill. How much less? Well, the ratio was 3 to 2, because the ratio of 60 to 40 is 3 to 2. So literally we got an answer of 40. There's a long summary of what we already just did last Wednesday, but it's trying to say, we have to take very seriously these definitions. Average speed really, really means distance over time. And that's the only way to, or at least at this stage, that is the way to calculate it. When you get an answer for average speed in the end, you will see that on the one end, you can't just like take average 2 numbers to get the average speed like a lot of people want to do. But But nonetheless, the answer you get, it does make sense in terms of the meaning of average. It just forces us to take that meaning and the meaning of distance and time that much more seriously. Okay, that was a long, okay, that was just like supposed to be the review, sorry, of what happened on Wednesday. Now I'm going to say, we're going to go more with that. You're by Wednesday. Oh, well, yeah, well, kind of a bummer that we won't actually have the discussion this Wednesday, but whatever. What I'm going to discuss this Wednesday of sheet 3, which homework 3 seems like out of nowhere, right? Like we just started doing numbers, we started doing equations. And then I recognize homework 3 is like all this English and all this like thought questions that don't seem to have strict answers. I get that. The point of homework 3 is it's going to unpack even further some important aspects of the meaning of speed and velocity. Specifically, what we're going to find out on Wednesday is that another dimension of speed and velocity that are super important to problem solving. Like it's not just abstract philosophy. What we're going to find out Wednesday is that speed and velocity are not like temperature and mass. Speed and velocity, super important concepts in physics. And so are mass and temperature, but they're not like mass and temperature. Just as a quick like sneak preview to Wednesday or whatever, mass is a property that a thing can have, like an object has a certain amount of mass. Or a system, a room, a climate can have a certain temperature. You can have one object that has a mass or one system that has a temperature. Temperature and masses are properties of single objects. What we're going to be finding out Wednesday is that average speed and average velocity are not that way. They are not single, they are not properties of single objects. They are relations that appertain to pairs of objects. If you just have one object, you can't have a speed or velocity, as it turns out. In order to have a speed or velocity, you need two objects to compare to each other. Speed and velocity are actually comparisons. That's what this sheet right here is meaning. That's what we have to get into Wednesday with the whole train of thought homework. That's what that's trying to get at. But before we do, we're going to do one last example to probe the numbers of speed and velocity. This may bore some of you. It might frustrate some of you. I don't know. But in this class, probably not. Hopefully not. Maybe I don't know what you'll do with it. But I want to do the very last example on homework 2 before we move on to homework 3. It's 3:30. Okay. Yeah. So I want to go to the very last example on homework 2. The last problem, correct me. I mean, hopefully you have it in front of you. The last problem is called GrammaGrimm. It's like about Little Red Riding Hood or whatever. I'm restating it and redoing it all right here. Like first, okay, I'm giving you the diagram and the fact pattern as I understand them. Please correct me if I'm wrong about any of this or if I'm confusing about any of this. Also, let me just change the view. So are we recording? Okay. So like Little Red Riding Hood or whatever goes to a grandma's house and it's stated that grandma's house is 80 kilometers away. It's 80 kilometers out. Okay. And we're told that the average speed or the average velocity of Little Red Riding Hood for that journey is 40 kilometers per day. Okay. Weird units perhaps, but totally legitimate units like distance per time. So on average, Little Red Riding Hood travels at a rate of 40 kilometers per day. If it's easier for you to picture, by the way, you could totally picture that as a constant. Like you could picture that she's just always going 40, or you could picture that she speeds up and slows down, but then it averages out to 40. Same works, whichever's easier to picture. But she goes out at 40. Okay, that's a given. Another given is that then she comes back and she comes back the same trail, the same road, 80 kilometers back in. What we're not told is how fast she goes on the way back in. In fact, it turns out that's what we have to figure out, and we will in a moment. But there's one other fact that we're given. We're given one other fact, which is that for the whole round trip, she averages a speed of 80 kilometers per day. Okay. And the question turns out to be, I'm going to go to the next page in a minute. Well, yeah, I guess I'm going to go to the next page. So I've done my diagram and fact pattern, right? Now I'm doing like, well, what is the question? So the question is, what is the average speed for the return trip, the in trip, such that all these facts hold true and such that she accomplishes a round trip average speed of 80 kilometers per day. So let's pause for a second. This is now more practice of the same thing in a way. This is exactly like, I shouldn't say exactly, but this is the same type of problem as homework 2, the hill figure problem, it's all about like average speeds and round trips and all of that. Same type of information. It's just given in a different package. That is, homework 2 was, we were told the out trip average speed, we were told the in trip average speed, and we were asked, okay, what's the round trip average speed? And we found that we could find it as long as we were careful. Here, we're given the out trip average speed and we're given the round trip average speed. We're trying to find the in trip average speed. Okay, so it's the same problem, just with different givens, which should mean that we should be able to figure it out with the same type of thinking. And the only thinking available to us is average speed equals distance over time. Okay, so this really is just like the last problem. Maybe, but is it worth it? I mean, the mere fact that it comes after the last problem probably indicates that it's related to it, that it builds off it, that it's similar to it. But if it's worth your time, that I gave you another problem, it might be somehow one touch more challenging or more interesting. Otherwise, it's probably not worth it. So I think it's fair to assume this is going to be like the last problem, but maybe a touch weirder. I don't know. It is. So the first thing I want to say about if we took the last problem serious, and I can go back anytime. I'm going a little fast because I already wrote the notes. I can go back anytime. But let's first realize, if this is just like the last problem, the hill figure problem that we just did, then same thing applies. Like, this is all about average speed. Average speed, triple equal sign, distance over time. Average speed does not equal average of 2 speeds, right? That's what we sort of learned in the last problem, or we found out the pitfalls of making that mistake. So same thing here. What's very, very common, and especially if you did all the homework, I mean, most people did the homework before I went over any of it. So if you did make a mistake in problem 2, it's totally understandable and fair that you might make the same mistake here. So it's like no shame, but let's be honest, like a lot of people classically for this problem will put, and hopefully you are looking at your homework, whether you got it back or not, and you probably didn't. If you're looking at your homework, you might well have put that the answer is 120. If you put 120, that is not crazy. That is not unreasonable. You are not going to burn in hell, and you're very responsible. By the way, if you put 120, you probably are a very responsible student who is paying attention and doing the right thing and like not robbing old people in the subway. But it is wrong. Like if you put 120, it is wrong. And now, and you might not have seen why before we went over. I don't know why I'm screaming. You might not have seen why before we went over the hill figure problem. But now that we've gone over the hill problem, you might start to see why 120 is a fair instinct. It's an understandable instinct. It's probably the best possible wrong answer, but it is a wrong answer. All right, touche. Fair enough. And in these crazy times, then yeah. Oh, I actually, that is so funny. I actually have to say something serious about that in a minute. Don't let me forget something about points about that. But okay, touche. Fair enough. I'm trying to think. Wait, am I a criminal? I mean, am I a criminal? Do I have any good criminal story? Oh, well, you are. You know, that's a funny thing. I don't know. Have you ever had the experience? When I tell people I teach at John Jay College of Criminal Justice, people often do think that means I'm teaching physics in a jail, like to criminals, like, which, I mean, you and I know I kind of am, but like, let's not tell anybody. But anyway, well, yeah, not most people, but no, sometimes that's what it sounds like. Yeah, I've had that experience before. I mean, okay. But yeah, it does. There's no way to know unless you know. I mean, College of Criminal Justice does kind of sound like we're imparting justice to criminals, right? I mean, which we are, but we are. All right, I'm gonna keep going. Oh my God, this class, I'm gonna miss you in it. We are bought. Oh, taught. Well, actually, that is true. Nicholas, I don't even know if Nicholas is joking or not, but there is some truth to that. Oh my God, guys, let's be criminals. Wait, yeah, no, that is true. That's kind of what I thought Nicholas meant. And yes, in fact, yeah, you're right. Yeah, and no, and you're right. And wait, okay, very quickly, do I have a friend? Hold on, do any of you know Dr. Roberts? Like, you haven't taken instrumental yet. Do you know Dr. Rob? I'll tell you later a funny story about Dr. Roberts and that, but okay, anyway. Now Misha's getting into the like emoticon emoji thingy and bobber thing. But okay. Oh, just darn it. You know, the other reason that I do indulge all these jokes and stuff is like, the thing is, they do show that you're paying attention, right? You can't make those jokes unless you just heard what I just said. So like, yeah, we're not, what? Wait. Yeah, well, there is truth to that. But, well, don't get me, don't get me. The truth is, ultimately, in the end, you're doing the right thing. Like, it really is true that in the end, crime doesn't pay. It really is. But what? Oh, no. Oh, no. I'm so afraid. Yes. Okay. I will write you all recommendations to jail. Okay. Oh no, I guess you want to be successful criminals. All right. I'll write you, you want to be successful criminals. So I'll write you recommendations, not to jail, but to the White House. What? I didn't just say that. And which president did I mean? I don't know. I'm just saying, I didn't say it. Okay. 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 Yeah. Okay. Wait, what? I don't even get that. All right, I'm totally going to shut up. No, I'm not, but I'm going to, all right. Is there a way to, okay, but what was I? Yeah, that's what my son, yeah, break you out. That's what my son always says to me in like battles in Mario Kart, you know, when you get in the, you know, the things when you, and then he never does. But okay, well, you should. Good luck with that. Okay, no, wait, all right, no, this is, I'm turning away because you're playing with my ADHD, which is like very easy to do. How many ADHD physics professors does it take to change a light bulb? Fish. Okay, wait, what was I saying? Really, what was I saying? 120. So 120 is wrong. Okay, 120 is not the answer. It's reasonable. I know if you put 120, it's because you're thinking, oh, I went 40 on the way out. I want to average 80. I want to average 80 for the whole thing. So I guess I better go 120 on the way back, right? If you put 120, you're thinking, oh yes, like he gave me the average and he gave me one of the two items. I need to find the other item. So he's asking me, what's the other item? What's the item which when averaged with 40 makes 80, right? And so you might have said 120. And if literally that was the question, that would be the answer. But average speed does not equal average of the speeds, right? Average speed equals total distance over total time. We're going to find out that 120 will not work as an answer. It's not high enough to actually produce an average speed of 80 for the whole thing. So, but I know that Monday morning quarterback, like I know that because I'm the teacher, but say I'm doing this homework for the first time. Like, how am I supposed to find, like, how would I know that? Well, you wouldn't necessarily at first, but what you would know is the one and only thing you know, which is average speed equals distance over time. Start with general principles that are true and work from them to make them particular and numerical. Like we don't start with relevance and try to make it true. We start with truth and we try to make it relevant, right? So if I'm just following the pattern of doing homework here or solving problems or doing an exam, first I wrote the fact pattern of the diagram, that was number one. Then I wrote down with the question, that was number two. Now here, I do the next step. Before I start crunching numbers or anything, I literally, since I'm trying to find average speed, I write down the one and only definition or true statement or thing that's always true about it, which is average speed equals distance over time, right? And I could write that as an equation if I like, but I don't really have symbols for that yet. I mean, in general, these will be equations. We're always about velocity and displacement, but I'm writing it in English because I don't really have symbols for like speed. I have symbols for velocity and stuff. So I write it in English, definition, average speed, triple equal sign, distance over time. That is true, even if I don't know what to do with it yet. It's points on an exam, even if I don't know where I'm going with it yet. And then I turn the page and then I just do look in the chat just to make sure. Right. Crime, funny, crime and justice, justice. That's funny. You know what they say? Those who judge do not matter. Those who matter do not judge. Okay. All right. So up at the top of the page, average speed equals total. All right. So now I'm modifying slightly. I'm just going to remind myself now, average speed equals distance over time. That means the average for any given interval equals the total distance for that interval over the time for that interval, right? Like go back to homework one in your mind. Don't forget, we had like different segments of that experiment. Like we went this way, then we went that way, and then we went that way. Each little segment had its own information, its own little distance, its own little time. Each little segment had its own average speed. Like, and just like in a class, like you do have an average at the end of the semester. Okay. You do have an average at the end of the semester, but that doesn't mean you don't have an average for the first half of the semester and a separate average for the second half, right? You could take averages over any sets of values you wish. So I'm just reminding myself here that the average speed for the whole round trip, or well, for any segment, is the total for that segment over the totals for that segment. So so for the round trip, for the whole thingamabobber, the average speed equals the total distance over the total time, just like we said yesterday with hill figure, right? So that is to say the distance out plus the distance in, that's the total distance, right? Over the time out plus the time in. Now, and again, this is because we're looking at distances and speeds here. Like, make no mistake, if I ask the average velocity, I mean, the average velocity for this whole round trip is definitely 0. Right? Like that's true. It's just not as interesting. I mean, that's just definitely true for any round trip. So there's not much to do with that. But the average speed, I said I want for this whole thing to be 80, right? So let's fill in what that means. I said that the average speed for the whole thing was 80. So what does that equal? That equals the total distance over the total time. So I'm like looking at the, I guess you can see this at the bottom here. I didn't know I could do that. That's sort of cool. Okay, the bottom, the total distance is 80 out plus 80 in, 80 kilometers out plus 80 kilometers in. Then all over the time out plus the time in. Okay, so let's pause. So now I'm starting to fill in numbers. I'm doing step number 4, particular application and work, right? Now, I have a lot of these numbers. Like I filled in all these 80s and stuff. Let's look about times. Like, all right, time out. Do I have the timeout? I'm actually going to put that in the chat. Like, this is my question now. So just putting in the chat, just as a, so I'm pausing here to ask anybody and everybody, do we know, like, because I'm trying to fill in numbers here, right? Like, yes, awesome. That was fast, John. And yes, John. And by the way, I shouldn't even say yes that fast. I mean, because I should have given more people. Other people could still say stuff too. And it doesn't matter if you're the first person or the, oh, my son is about to come in. We're going to be interrupted in a moment, I'm sure, hopefully briefly, but one never knows with 7-year-olds. But I just want to say, John is right, but that shouldn't preclude anybody else from putting anything in the chat, because first of all, you don't have to be the first one to say it. You could totally agree with him, and that's still valid. But also, you could take it another step. But and I also want to, and you could also be wrong, and I want to talk about that for a minute. But John is right, and let me be clear why I'm even asking, like why I just put that in the chat. Because notice, we have an equation here written. I'm using the only equation that we know. I'm using the only equation that we know and seeing what we could figure out from it. And right now, just plugging in all the numbers, it sort of looks like we have one equation and 2 unknowns, and that's not just workable. But if we know either of the 2 pieces of information in the denominator, if we know either one at all, and I'm starting with the first one, then that would mean we only have one unknown, so we don't have an intractable problem here. So, okay, so I'm looking at, so John saying yes, so John, yeah, totally, yes, and yes. I totally agree with John and Alyssa. I'm going to go with what they're saying. In fact, I'm going to pause for, I totally agree with you. Yeah. Oh, great question, Maisha. Yeah, actually, yes, except what I actually mean by out, I mean there. So I actually mean the time it takes. Daddy. Hello. Hello. How are you? Good to see you. Oh, okay. Love you. Welcome back. Was it good? Hi, guys. Was it good?
Yeah, it was good.
Great.
We did a few rides.
Awesome. Okay, I'll be honest. Awesome. See you. Okay. They came from the fair. Yes, that's how I feel too. Yes, thank you. They were just at a county fair. I'm so too. Oh, thank you. Yes, me too. So, see, COVID has its advantages, doesn't it? Oh, but no, Maisha's very good. Oh, and she even, wow, okay. So Maisha's very good question. Like, yes, but the opposite. By time out, I mean time there. by time in, I mean time back. I mean, I guess those are weird terms. But so what I'm asking right now is, do we know the time that it took to go to grandma's house? Do we know that time? And I don't, and tell me if, oh, you got, I'm not sure if that, thank you. Okay. But wait, but I'm hopefully I'm, oh, wait, great question. But no, I sort of mean, so in my mind, there's traveling there and then there's traveling back. And neither one is stationary. Like there's an out trip. So this is kind of like hill figure, only it's like horizontal. She went out 80 kilometers to grandma's house and she went at an average speed of 40. And then she came back at an unknown speed. But so what, and coming back is the thing that we're trying to figure out. Ultimately, we're trying to figure out like the purpose of the question, or the question of the problem is like, how fast must she have traveled on her way back, her way in order to accomplish something? So I'm saying, so we're at, but I'm saying, but we were told how fast she was traveling on the way out, on the way there, on the way, on the first leg. She was traveling at a speed of 40 kilometers per day. And the distance was 80 kilometers. So tell me, so what I'm ultimately saying is, I think that John and Alyssa and maybe some others are correct. I think what, oh, let me just see. Okay, cool. Yeah. Exactly. It's referring to the two trips. That's right. Because again, that's right. So time out is one trip and time in is the other trip. And what I'm saying in background is like, so the round trip, the average speed for the round trip is the total distance of the round trip, like there plus back, divided by the time there plus back, like that, right? And I'm saying the time. Oh, cool. Oh, who's a well. Thank you, Alyssa. I'm glad at least one of us can explain physics. But yes, no, thank you, Alyssa. Absolutely. In fact, if Alyssa starts getting more subscribers on her YouTube channel than mine, we all have an issue. No, so what I'm saying is we're ultimately focused on the trip in. Like that's what the question is ultimately asking about. But if maybe we have enough information about everything else, maybe we can reduce this whole question to one unknown. So that's why I like sort of highlighted time out. And that's okay, she gets points for that. And what I'm saying is that John and darn it, John and darn it, who was it? Oh, and Alyssa. Yeah, John and Alyssa are pointing out, look, this next page, they're saying, look, you do know the time on the way out. That's not an unknown. It wasn't given in the problem, but it's not an unknown what the time on the way out is. What they're saying is, well, here we go, this page. We're saying the time out, we can figure it out. Yes. Average speed equal, and I'm just going to rearrange again. Note I only have one equation, but I'm constantly rearranging it and reapplying it. I'm trying to show you how powerful this one equation is, and I'm also trying to show you how like, well, yeah, just that, how powerful it is, but how versatile you have to be with it, how flexible you have to be with it, and how you shouldn't resort to anything but it in these times of woe. So average speed equals distance over time, right? But also, I'm trying to show about reference frames. Kind of like the title page of these notes said, like notice one page ago, we were looking at the average speed for the whole round trip and we were plugging in appropriate numbers, the distance for the whole round trip, the time for the round trip. Now I'm shifting my focus, like I'm joining John and Alyssa and others to shift my focus and just look at that one segment out. And I'm saying even for that segment out, the equation still applies just as long as I put in the appropriate or consistent information to that equation. So average speed equals distance over time out. Like if I just look at the out trip now, I should say, like the trip there, right? And if I want to find, I can rearrange the equation even before I put in numbers. If I want to know the time out, I can say, this is the thing that Alyssa said in the chat. And yeah, well, this is the thing Alyssa said in the chat. That time, if average speed equals distance over time, then I can multiply both sides by time. And again, notice I can do math, even if it doesn't look like, even if it's English words, right? Like that's the point. These are just logic. Like multiply both sides by time and divide both sides by average speed. So time equals distance over average speed. Always, always true, right? If it's true that average speed equals distance over time, and if it's true that distance equals rate times time, that's just a rearrangement, then it's equally true, even if it's awkward to say or doesn't come up as much in your life, it's equally true to say time equals distance over speed. And in fact, then I'm doing now John's thing of actually taking the numbers from the problem and plugging them in with the units, and notice the units work out. Like for the trip, and this is not an answer to the question. We're like not done. I mean, we're done soon, but we're not done with the question. We're just getting a piece of information that I think is important. Yeah. Oh, good question, John. All right, really good question. I'm going to pause on that I'm going to get to that in 1 minute. I mean, to be honest, the answer is no, but I want to say many things about that in a second. It's a great question. So I will get to it. But yeah, I mean, but honestly, the answer is no. I hate saying no. I just hate that word. Oh, cool. We got like had a Catherine moment there. That was like, so she should get points for that. So what I'm saying here is the time out is 80 divided by 40. What? Oh, that's funny. Okay. I was nervous there for that. That is very funny. And you know what's even funny, but oh, that's no problem, Catherine. It was good to see you. And the Nicholas thing, I have to admit that is very funny. And the worst thing is, right at the moment I said I can't say no, I was actually trying to think of a joke like that, but I couldn't. So I almost want to give you an A just for that joke. But no, I can't. Sorry. I can tell you this though. That doesn't mean you can't get an A in the class. You could totally get an A. I could even compute and record an A, but I can't give you an A because it's not mine to give. Grades are not gifts. They are computations of earned realities. Okay. What? Okay, I'm totally going to ignore that's just mean. Okay. All right, on that. Sorry. My laugh certainly didn't sound peaceful, did it? Okay. First of all, I almost want. Wait, I don't even know what you're agreeing with. Wait. Okay, dude, are you kidding me? Do you understand that I almost might say yes to that? Because good luck. Like, do you understand what a chat? I mean, I don't even think you could do that for a quality YouTube channel, let alone. But yes, if you do, especially because I would get monetized at that point or whatever, I would totally. I mean, everybody has a price, right? I mean, I would totally yes, but no, but yes. We'll get back to that. If nothing else, just to make my 17-year-old son pissed off. But wait. Well, 100,000 subscribers is the starting price. But wait, okay. Wait, okay. Wait, all right, hold on. But this is funny. And okay, I'm also gonna, if you've ever seen the cartoon Peppa Pig, if anybody's ever seen the show Peppa Pig, I believe they were the original LMAO. Like if you ever watch the end of every episode, they make it like a ridiculous sitcom where someone makes a really bad joke at the end, right after the conflict is resolved, and then everybody like laughs at the joke, and it's like, and the episode ends. But because it's a cartoon and a very like cutely, primitively drawn cartoon, the way whenever they make the joke at the end of Peppa Pig, and then they all laugh, they all fall over on the ground laughing, right? Like they just go like 90 degrees from these like upright pigs to like horizontal pigs, like bouncing up the ground. But the thing is, none of them have any butts at all. They're just like drawn like straight. So when they fall on the ground, instead of like falling and bouncing up and down, they just like literally go like up, like and down like that because they don't have any butts. So I feel like that is actually what LMA, like they are literally laughing their ass off. But anyway, okay. Okay, yeah, good luck. Okay, seriously, good luck. But oh, that's funny. Okay. The A fell. No, it didn't. No, he totally still has an A. Okay, he does, by the way, right now he does have an A. We'll just see. Can I be the oh my god. All right. Okay, wait. This class isn't reading. Oh god, I have to say the Lord's Prayer before it's ever gonna lead me not into temptation, this class. Okay. What I'm trying to say right now, that I believe John and Alyssa and this board proves. Wait, sorry, that wasn't a joke. Did I just lose you all? Something just happened. Wait, are you still here? Oh, you are. Okay, something happened on my screen. What I think this board, okay, thank you. Yes. Okay, cool, cool. What this board proves, what John proved, what Alyssa proved, what others are proving is that the trip out must have taken 2 days. Okay, like just in English, if you just back up and just think about it, like, oh, the trip out was, and that's not the answer to the whole problem. That's just a piece of information that I think we need and can use. And that's just that, oh, if on the way out it was 80 kilometers in distance, and if on the way out you were going 40 kilometers per day, well, then it took you 2 days, right? I mean, like, I think many of you can see that in your head. I'm trying to show it rigorously on paper and show that it's not just like some lucky guess, but it is just like saying if you have 60 miles to travel and you're traveling at 30 miles an hour, well, you're traveling 30 miles every hour and you have to travel 60 miles. So you have to travel for 2 hours. That's all this is saying so far, right? But I just did it in equation form and all that to show. So, and notice the units do work out nicely and all of that. We are, okay, cool. Now that is not the answer to the whole problem. What I'm just doing, right, but I'm saying it takes 2 hours to go out. What I'm really saying is, okay, if you go back to this page, if you go back to the sort of condition of the whole problem is that we have to go an average of 80 kilometers per day for the whole round trip, then we're starting to fill in here whoops, like we actually can start solving. Like in the one equation we have to work with, average speed equals distance over time, we actually have all the information except one piece. We have one equation, one unknown, right? And that is solvable. Like we should be able to solve for that one unknown. Now before it, right now, and then we'll pretty much have an answer, pretty much. Why do I say pretty much? Because the one thing that's unknown is the time in. Now because we just showed that we know the time out and we know the distance out and we know the distance in and we know the average speed for the whole round trip. The time in, like the time back from grandma's house, the time in, we actually don't know. The reason we don't know it is if we tried to do the same method as we did a second ago, that John and Alyssa said, if we tried to do that same method of just saying, oh, well, I mean, I mean, time in should just be distance in 80 kilometers divided by speed in, like, why doesn't that work? Well, because the speed in is not only unknown, but the very thing we're trying to get here. Okay, so this is what I'm really trying to say here is the time in is the one unknown we have here, because time in is just a cute way of thinking about the average speed in. Like, I don't know which one we're going to get first, but they're intimately related. We know that in it's 80 kilometers of distance. If we know how much time we took in, we know the answer to this whole question, average speed in, and vice versa. Like I'll say that one more time. We're trying to figure out how fast we're coming on the way in. Well, we know how far we're coming, 80 kilometers. If we just knew the time on the way in, if we knew, for example, that we took 1 day to come in, if we knew that, which we don't, but if we knew that it took 1 day to come in, well, it's 80 kilometers and it took us 1 day, then the speed would be 80 kilometers per day. And that would be the answer to the whole question. It isn't, because that's wrong, but that's what we're looking for. The average speed on the way in is what the question is asking for. What I'm trying to say here is all we have to get in order to do that is the time on the way in. And now I feel like we have one equation, and to get it, we have one equation, one unknown. If we solve for the time on the way in, that is just about equivalent. That's one tiny step away from answering our whole question. Okay, so I'm saying right? Just to be as clear as we can, what we're looking for is the speed in. The speed in is definitely distance in over time in. The distance in is 80 kilometers. So if we can just get the time in, like we're pretty much done, right? So now I can solve for the time in because I have everything else. So here we go. Like, I'm just waiting for the page to scroll. Right. Okay. So here we go. The round trip, the average speed for the whole thing is 80 kilometers per day. That was a given in the problem, right? That's the condition of the problem. How fast do we come in such that it's 80 kilometers per day for the whole thing? So the whole thing is 160, right? Can I point to this? The whole thing is 160, like 80 plus 80. That's in the numerator. The whole time is 2 plus question mark. I'm just calling it a question mark. I could call it X. I could call it D. I'm sort of on purpose calling it a question mark because I'm just really trying to emphasize. I'm doing math, but I'm just trying to show you that math is just English in symbols, if you know what I'm saying. Okay, like I'm looking for that question mark. I'm looking for living in all the wrong places. I'm looking for that question mark. I'm looking for the time on the way in. And well, I have an equation here, 80 equals 160 over 2 plus that question mark. So I can solve for that question mark, right? Oh, and I'm just reminding you here what I already, yes, of course. Why wouldn't there be one? Yes. Okay. Okay. Yes. And that's my price. You have to sit through a concert of mine and you have to get 100,000 subscribers. Okay. So wait, next page. Okay. All right, I'm kind of over explaining this, so there's a surprise, but I think I already just said all this. Okay, I think you already, I just already explained this. Okay, so here we go. That's funny. Okay, so 80 equals 160 over 2. I'm saying this sort of over again and again. Partly, and why am I saying this? None of you I would expect to write all this stuff just to solve this problem. But the reason I'm like saying so much is I'm kind of defensive, right? I'm trying to really show you that, especially because when you see the answer, you might find the answer sort of frustrating, or you might find this sort of like, it seems like almost like a trick question. But I'm trying to show you not only why the right answer is right, but I'm trying to show you why it's actually kind of fair. That like, even if all we know is average speed equals distance over time, as long as we're really willing to grind it and we're really willing to apply it here, apply it there, flip it over, apply it again, we can get a whole set of steps out of just that one equation, as long as we really see what we're doing. So 80 equals 160 over 2 plus question mark. So I multiply both sides by 2 plus question mark. If that doesn't seem like math to you, then change the question mark to an X, like, and then it is, right? So 2 plus question mark times 80 equals 160. So then I divide both sides by 80. So I have 2 plus question mark equals 160 over 80. So then the last step, I have question mark equals 160 over 80 minus 2, right? Like this is just algebra, only I'm using a question mark instead of X, just to keep us flexible and interested and insane. So then I get question mark equals 0. Now, I'm going to look at the chat in a second, but now look, that's not an error. It's also not, I'm not even sure. Do I FOIL? I thought that was a joke for a second. Hold on. Wait, that's funny, but hold on a second. FOIL, you don't have to FOIL. This is more like distribute. And it's actually not even distribute. It would be distribute, except I divide both sides by the 80. So wait, that's a really good question. Assuming that, okay. Oh, okay. You would distribute. You would, and that's a very valid question. Is a very valid question. But I'm looking. Oh, I see. Oh, AA 60. Hold on. Yeah. But I would do that, except for the fact that what I'm trying to solve, and maybe it's annoying. Look, okay, hold on. I'm going to change the question marks to X because maybe the question marks are what's throwing people off for no good reason. I mean, I don't know why I didn't, but I would FOIL, but I don't have to because since what I'm solving for is that question mark. Okay, so I'm going to call it D now. That's what I'm solving for is that D. That T, that time. Since what I'm solving for is that time. That's what I'm solving for. Then that's what I'm trying to isolate. So in fact, like I multiplied in this step right here, I multiplied both sides by the entire denominator, 2 plus t. Also, if the units are annoying, I mean, units are important in science, but if you just want to look at the math for a second, like get rid of the units if they're throwing you off. So I just had 160 over 2 plus t, but I'm looking for t. So I multiply both sides by 2 plus t. So I have 2 plus t quantity times 80. And because it's a quantity, I totally understand why John is asking what he's asking. But then the fact is, so I would like distribute the 80 or something like that. I like normally would, but I'm actually looking for the t. So I divide both sides by 80. It's kind of like cross multiplication in a way. I divide both sides by 80. So now I have 2 plus t equals 160 over 80. So I have t. So I subtract 2 from both sides. And I have t equals 160 over 80 minus 2. But I'll add a step here too, so it's not. So I'm saying then that t equals 2 minus, like 160 divided by 80 is 2. As in fact, John and Alyssa and others told me a second ago. So oh, no, wait. Hold on, no. Jessica's totally right. Wait, I'm not up to date. This is not an answer yet. No, Jessica's totally right, Everybody remain calm. And I didn't see all the other stuff in the chat. And I think, okay, cool. John gets it now. Cool. Thank you, John. No, Jessica's right, but she's one step ahead of me. She's totally right. She should not change her answer. No, she's totally right. But bear with me for a second to make sure we see, because this is not the answer yet. What I'm saying here in all this math, in the math, I'm saying that t, specifically t back in, the unknown time that we don't know, the time that it takes for Little Red Riding Hood to get back from grandma's house apparently is 0. Apparently, which I have to explain, but this is t in, like as in the t out was 2 hours, the t in apparently is 0. Now that's not, the question wasn't asking about t. I think we need t to get the answer. The question was asking how fast should Red Riding Hood go on the way back in order to make the whole problem work, to make an average speed of 80. And what Jessica's saying is right. It's the correct next step inference from this. In other words, if you trust this math right here, and I'm going to try to put it in English in a second to make sure you, well, I'm going to put it in English. Well, no, okay. If you trust this math, what this math is saying is that in order for the entire round trip speed to be, in order for the entire round trip average speed to be 80, what this math says is that the amount of time it would have to take Little Red Riding Hood to get back from grandma's house would be 0 amount of time. That's what this math says. I'll try to explain why it says that in a minute, but that's what it says. It says, no, right. So it says the time, like what we just figured out is that the time in would have to be 0. That's what we just figured out. But since the question of the problem is how fast should she go on the way back in? Well, if this calculation is correct, that she would have to get from grandma's to her original house in 0 time, which I'm not saying is technologically possible. But if the math is saying she would have to get there in no time, then the answer to the problem of how fast would she have to go is, oh, she would have to go at infinite speeds. Or she would have to get there like this. She would have to go, in other words, no finite speed would be fast enough. She has to get to back in 0 time, according to this math. So the answer to the question wasn't asking how much time does she have. The question was asking how fast does she have to go? And Jessica's right to say, however Jessica got it. I'm not saying Jessica did every one of these steps. She might have thought about it slightly differently. But somehow, somewhere in Jessica's mind, she realized, oh, wait, this is messed up. She would have to get there instantly. And since the question's asking how fast would she have to go? Well, to get somewhere instantly, you'd have to go infinite speed. I'm not saying that's a new formula or a new conclusion. And you might say, well, I didn't know that. Well, it's not a matter of knowing. I'm just saying, like, if the lesser and lesser time I want to get somewhere, the faster and faster I'd have to go, right? If I want to get somewhere in 1 hour, I'd have to go 80 kilometers per hour. If I want to get there in a half hour, I guess I'd have to go 160 kilometers per hour. If I want to get there in 15 minutes, I have to go 320. The less time I want to get there in, the faster I have to go. If I want to get there in no time, that's like distance divided by 0. There's no finite number that's going to be big enough to do that. What we're saying here is this. Well, So on the blue on the side, it's saying that the answer to the question, how fast would she have to go on the way back to do this, is she would have to go infinite speeds. You could put that as a proper, if this were an exam question. And look, I know it's not supposed to be a trick question. It's not meant to be frustrating. Just to be clear though, say this were an exam question or something like that, and I really will, oh, okay, good. And I will look in the chat in a second. But no, Jessica's totally on top of this. And again, I only see sort of like half of what's popping up in the chat at a time. Like I don't see her whole thing. I will look at her whole thing in a second. But I'm totally saying right now, if this were an exam and you're wanting to know like what would be the correct answer for full credit, assuming you showed all the work and all that, if you put infinite speed, you'd get full credit for the correct answer. If you put no speed would be fast enough, full credit, correct answer. If you put it cannot be done in the practical technological world, or like no object could go fast enough to do this, it can't be done, you'd be correct. If you put anything like she would have to get there instantaneously, therefore she would have to travel at super, impossible speeds, you'd be correct. That's what our math is saying. Now, okay, but now let me look in the chat for a second. Oh yeah, no, cool. No, you're totally right. Right. And what John's saying, right. So what I'm saying, and this is a little, I'm getting louder because I am a little defensive about this. I know this question, or at least this answer might potentially frustrate some people. It might feel like, all joking aside, it might feel like I'm trying to trick you, like, hey, you fell for my trap. I'm not trying to do that to anybody. I mean, yes, I'm asking this question because I think there is a common answer of 120. I think it's possible to, in a way, underthink this question and not see the depth of it. It's very common not to get it right. And I'm trying to show you why the right answer is actually kind of surprising and tricky. And indeed, the right answer is, like, just like with, okay, so Hill figure was a little bit tricky in that it seems like the answer should be 50, but it's actually 48. And you might feel like I was trying to trick you there. I really wasn't. I was trying to show you that physics is tricky. But again, why I think it's fair, and I am defensive of this because I don't like tricking people. And I certainly don't want you to think that I'm going to try to trick you on the exam or something like that. Like really. But what we are, I know it actually, and even there again, Nicholas is the master of the half joke, half not. I know that what Nicholas just put in the thing is like half a joke, half not. And that's right. Physics, look, it often feels like one big trick. But actually, the trick of physics is that, well, there's many, is that it is not at all easy because it's shockingly simple. The trick of physics is that it actually forces us back to fundamentals all the time in ways that we always think it's going to be harder in a way than it is, or we always think we've got to invent some new wheel to do it. And it always turns out that the answer, it always does seem like a trick because there's always a surprise in physics in a way. But the big surprise lesson is that if you actually don't try to overthink, if you don't try to look for the trick, if you just actually proceed step by step from the fundamentals and you stick to the fundamentals, the tricks reveal themselves. Like, you don't have to master the tricks. You don't have to beat the tricks. The surprise, so what I'm saying here is, just like with Hill figure, and I know we have 4 minutes, but I think this is worth it. Okay, so the answer here is infinite speeds, or it can't be done. But let's back up for a second. Wait, and let me say also why, like all this math that we just did, it might just look like a bunch of like arbitrary math. Like, you also might be thinking like, okay, that's fine, but I would never think to do all that. But look, just actually in English, here's what we're saying about this problem. And then again, I am going to defend it for like a minute and a half after that. But here's what we're saying really just did happen. Even if you just like try to picture it in your head or whatever. Okay, I'm afraid of the chat for a second because I'm not going to look at the chat for a second, sort of. But look, here's what we're really saying. In logic, in English, in like non-trick land, we're saying we had a 160-kilometer journey. Right? I don't care that it was out and back, actually. It's like we had to do 160 miles, look, 80 there, 80 back. And our goal was to make the average speed for the whole thing 80, right? So change the numbers if you like, or forget that they're kilometers or days if you like. The point is, we had to drive 160 kilometers and we wanted on average our speed to be 80 kilometers per day. Therefore, straight up, what that means is we had 2 days to do the whole thing, right? Like, just like, right? I mean, like, if you want to drive at 80 kilometers on average, 80 kilometers per day, but you have to go 160 kilometers, that means you want to accomplish your whole thing in 2 days, right? Like, right? But sidebar, or but subsection of the problem, John and Alyssa and others showed us that, well, in a way, so when we said like, okay, fine, we've got 2 days to do this whole round trip. So why don't we just figure out how much days we took up going out, and whatever we have left over, we'll allot that to coming back, and we'll find out what that is. And that's our speed for the way back. The catch is just because of the numbers that I gave you, just because of these particular numbers, not because anything's wrong with the problem, but because of these numbers, if you drove at an average of 40 kilometers per day on the way out, then you took up 2 entire days just to get out, just because of what the numbers were that were given. They looked like reasonable numbers, but they're not actually reasonable for the goal. We took 2 days to get out, but if we want to go at an average speed of 80 for the whole thing, we only have 2 days to do the whole thing. So we used up our entire 2 days just to get out. So in order to accomplish the goal, we'd have to get back in no time at all. So the answer to the question is, it can't be done. You would have to go infinite speeds or something, right? That's the answer to the question, is she'd have to go infinite speeds, or she'd have to get there instantaneously. It can't be done. But please understand, that is not the same thing as saying the question can't be solved. It's not a trick question. Like, we did a computation that proves there's one answer, which is infinite speed, or one answer, which is no finite speed possible. We're not throwing up our hands and saying this question is impossible to analyze. We're saying we analyzed it and found out that it can't be done. It's just the same trick as Hill figure, like, like you have to remember that average speed is distance over time. It's not average of speeds. As long as you remember that, you can get all the information you need to solve a problem. In Hill figure, and I'm about to stop, I see the time. In Hill figure, the surprise was, you might think it was 50, but it was actually 48. Little surprise, but you get it once you see it. Then here, same issue, but bigger surprise here. You might think the answer is 120 or some other finite number. Actually, the answer is infinity. Is infinity an allowable number in physics? Oh, yes. That's where we go with the next homework. And the next, we're going to have to deal with infinity in physics. Infinity is a real thing. That's why we deal with calculus. Calculus allows us to deal with infinity. Infinity doesn't mean we're over, discussion over, game over. No, we don't have that. Infinity is just means not finite. It means interesting in a whole different way, but we have a math and a science to deal with infinity. I mean, it's called calculus in physics. So that's where we're going. So if this was frustrating, please understand, again, this was homework, not a test. You get full credit for trying all that. It's just trying to, but also understand, you can't, and some of you obviously, like, for example, I think, and I am going to stop, but I think it's pretty clear that, like, and not to, like, I think Jessica got it right. Like, you can totally get this right on your own. You don't need, if you just literally stick to the fundamentals and you don't make up new equations. That's what I'm saying. But okay, physics is not all one big triple. It sort of is. Okay, but remind me next time. I know we have to end right now. Please note that there's a new portal that opened where you get 11 points for being wrong, and it would apply to some people today. I want to explain it in more detail to you next week. But please note, if you ever volunteer anything in this class that is concrete enough for me to say either that it's right or it's wrong, first of all, you can submit into the portal that says for right or for wrong. But if it's actually wrong, you can also double dip and submit it into the portal that says for wrong. You get points for being wrong. You can look at the portal again. I'll explain it more next week, but it's not a joke, because I know physics is tricky, but okay. Yeah, oh, that's funny. Okay, well, fair enough. No, and it definitely does apply to something some people said today. But that's also that portal, because I have such a hard time saying no, it also forces me to say no more, because I don't feel guilty, because then you get points. Okay. Yeah, no, if you have it totally, yes, please, that portal is not a joke. And you can literally triple dip. Like, if you participated today at all and you said something that was concrete that could have been right or wrong and it was wrong, you can literally put it in all those 3 portals and get all those points. That's no joke. Okay. Right. Okay. All right. I'm done. I'm going to hang out in case there's questions, but I won't see you Wednesday, but I will see you next week. You guys are a great class. Have a good day. Have a good day. And I'll look for those 100,000 subscribers. Cool. Oh, yes. No, I'm here for questions. Yes. Me, Maisha. Yes. I'll turn.
Yes. So